Okay, now let's take a look at the concepts of solving quadratic equations.
Polynomial equations, except these are polynomial equations, excuse me, of the second degree. So here's what I mean by that. Let me say that a quadratic, well, let me just say a standard, I should say, a standard quadratic equation is in the form of, in the form of, all right, so here's the formula, here's the standard form for a quadratic equation here. Ax squared plus bx plus c equal to 0. All right. So let's look at these types of equations. Again, I mentioned that we've already seen these types of equations back in chapter 8. Let me give you an example of that. All right. So back in chapter 8, we solved an equation such as this one: 2x squared plus 13x plus 15. Again, equal to what? 0. So here is a standard quadratic equation. And what's my a here? My a is what? 2. My b is what? 13. And my c is 15. So hopefully we can recognize a, b, and c right away without too much trouble. But again, we've seen this equation back in chapter 8, in particular 8.5 section, when we solved equations by what? By factoring. I mentioned this is a second degree equation. So a standard quadratic equation is what? Is a second degree equation, meaning the highest power is 2, highest exponent. All right. So let's solve this by factoring. So again, we've done this before, so I'm not going to go over this too much. But I want to focus on a technique that we haven't seen previously. Okay, so let's look at the factoring here. So let me do factor by trial and error. Again, we've done this before, 2x and x. All right, I'm looking for two numbers to multiply to 15 here. All right, so let's see here. Let's put a 3 here and a 5 here. Let's see if that will work. See, the middle term gives me 3x here, and that gives me what? 10x. So 3x and 10x will be what? 13x. So that works. So plus and plus, they're both positive here. Okay, then. So then after I factor what? I set the factors to 0, right? We've done this already again. 2x plus 3 equal to 0, or x plus 5 equal to 0. So then you solve for x in each equation here, so that's not too hard, as you can see. So we get 2x is equal to negative 3. Dividing by 2, I get x equals what? Negative 3 over 2. Okay, sorry for the 2 down here, all right? And here's subtracting 5 on each side. I get x equals what? Negative 5. So my two solutions for this equation will be what? Negative 3 halves. All right, negative 3 halves, and what? And negative 5, excuse me. So negative 3 halves, negative 5 are the two solutions we're looking for in this quadratic equation here. So again, we've solved these equations before back in chapter 8 by factoring. Okay, so let's extend that concept just a little bit here. Well, let's go and do one more by factoring, and then I'll introduce you to the new technique that I want you to focus on in this section. Let me go and clear out the screen here. Let's try this problem here. All right. Let's see here. Let's look at x squared plus x plus 5 is equal to the quantity 3x plus 2 times x minus 4. All right? So let's go ahead and solve this equation by factoring. Now, before I do that, again, one side has to be 0, as I mentioned. I remember when we solve by factoring, I want to use the zero products principle back on 8.5, zero products principle, that is. All right, and one side has to be 0 before I can do that. All right? So, but to make one side 0 here, before I do even that, let me go ahead and multiply out this side here on the right-hand side. Multiply out these two binomials. So the left side stays the same, x squared plus x plus 5. All right. Let me multiply this out in my head. Let me show how to do that. So 3x times x is going to be what? 3x squared, as you know. All right. Let's look at the middle term. This gives me what? This gives me 2x here. All right. And this gives me what? Negative 12x, right? That gives me negative 12x once again, right? Can we see that? Negative 12x. So what's that going to be? So this is 2x here. So this is what? Negative 12x. So this is negative what? 10x, right? So again, you can do it in your head here. 2x, positive 2x, negative 12x, so negative 10x. Can we see that? So we get negative 10x. And then positive 2 times negative 4 is going to be what? That's going to be negative 8. All right? So again, it's not too bad at all. Again, let's make one side 0. Now, I want to keep the x squared term positive, so it becomes easier to factor it that way. So let me go ahead and 0 out the left-hand side instead of the right-hand side. So in other words, let me cancel all 3 of these terms out. So let me subtract x squared to make that happen. That takes care of that. Subtract x takes care of that, and subtract 5. Again, do the same thing to both sides. So minus x squared minus x minus 5. Can we see that? Again, I'm combining a few steps here. So that takes care of the x squares, takes care of the x's, takes care of the 5. So I have 0 here on the left side. Again, one side has to be 0 before I solve by factoring, if you remember. All right. So I get what? 2x squared minus what? 11x minus 13. Are you with me on that? Now let's solve this by factoring. Again, we've done this before from chapter 8. So 2x and x for 2x squared. All right, once again. So let's see here. What's going to work? How about 13 here and a 1 here for 13? All right. Let's check the middle term. So this gives me what? 13x. All right. And this gives me what? 2x, which is going to give me negative 11x. Now, I want negative 11x, so I need that 13x to be negative, and the 2x to be what? Positive. So that'll give me negative 11x, which is what I want. All right? So I want the 13x to be what? Negative. So here's my 13x right here. Can we see that? So that should be negative. All right? Here's the 2x. That should be positive, right? So plus. All right? So once again, I set the factors to 0. So again, just recall how we solve these equations. X plus 1 equal to 0. All right, solve it. So add 13 to both sides. Again, solve each equation separately. You can solve this in your head if you want to. Right? Just add 13 divided by 2, basically. But I'm showing you all the steps here. So dividing by 2, we have our solution here of 13 halves. All right, and then here subtract 1 on each side, so we get x equals negative 1. Negative 1 there. Okay, so final solutions. Two solutions are what? 13 halves. And what? Negative 1. Okay, so we get 13 halves and negative 1, as our solution. We get 13 halves, negative 1 here. Again, how do we solve this? We first have to multiply this right-hand side, and then we 0 off the left side. So I can solve by factoring here. Then I factor this trinomial here by trial and error. Then I set the factors to 0, and then I have my solutions. All right, can we see that and finish this off without too much trouble here? Okay, but again, let's focus on a technique that I wanted to show you here in this section. Let me go and clear out the screen. All right, previously, if I have an equation like this, for example, x squared equal to 9, all right, and how do we solve this here? Well, we solve this by factoring. We subtract 9 on each side, if you remember, right? Then we have x squared minus 9 equal to 0. All right, okay, so let's look at this special case right here, where I have a perfect square equal to a number. In this case, 9 happens to be a perfect square, but this may not be a perfect square for the problems in this section. I'll do some examples of that in a moment, all right? So x squared minus 9, right? So how do I factor that? Well, that's just the difference of 2 squared, difference of 2 perfect squares, so it's x plus 3 times x minus 3 equal to 0. Can we see that? So therefore, if I set these factors to 0, don't I get negative 3 for the first factor and positive 3 for the second factor? Again, imagine setting these factors to 0 and solving them. Don't I get negative 3 here and positive 3 here? Hopefully we can see that here without too much trouble, without me showing you all the steps here. All right? But here's what I want to get at. So the original equation was what? X squared equal to 9. I'll just write it again right here. All right? But that means what? What number squared will give me positive 9? Well, there's two numbers that will, if I square it, will give me positive 9. Negative 3, if I square negative 3, that's going to be what? That's going to be negative 3 times negative 3, which is positive 9, all right? And then obviously 3 squared is also positive 9. So there are two numbers that if you square it, it will give me positive 9. So what that means is 9 has 2 square roots. It has, now typically we use the positive square root because that's the principal square root. That's called a principal square root. Again, reread section 10.1 if you need to on concepts of principal square root. But there's actually a negative square root of 9 and a positive square root of 9 is what I'm trying to say here. All right? So in other words, you can solve this equation without using this factoring technique and instead use a different technique called taking the square root of both sides. Here's what I mean by that. Let me copy the equation again. If I have x squared equal to 9, let me just do it down here. I can take the square root of both sides of the equation. Again, you do it to both sides here, right? And then the square root of x squared is just x. But when I do that, keep in mind again that there's a positive square root and a negative square root. Right? Again, there are two square roots here, positive root, negative root. So therefore, the answer will be negative 3 and positive 3. And when we write that is we get plus or minus, this is called plus or minus 3. Again, positive 3 or what, negative 3. That's how we write that. So we're saying x is equal to plus or minus 3 here. All right. So my point is this: when you take the square root of both sides of these types of equations, you get two roots. You get a positive root and a negative root. So therefore, your answer will always be plus or minus. So here's what I mean by that. Let's try another one. Let's look at x squared equal to let's make it. Let's do one more perfect square here. Let's make it 144. All right. So again, let's take the square root of both sides to solve this equation here. Okay, so again, I can solve this by factoring, by subtracting 144 from both sides again, and then factor is x plus 12, x minus 12. But again, we're not going to do it that way here. We're going to use this new technique that we had in this section here of taking the square root of both sides. So I'm going to get x equal to, again, when you take the square root of both sides, just remember you always get what? Plus or minus. And then what's the square root of 144? 12. So that's why the answer is positive 12 or negative 12. Again, keep in mind there's two answers here, right? There's positive 12 as one answer, and there's negative 12 as the other answer. Again, positive square root, negative square root. All right? Can we see that? So, so what we're trying to say is, and that is so because if you check your answer, 12 squared is 144. Negative 12 squared is also 144. All right? So again, there are two square roots here, but the positive root is called the principal square root. All right? But there's a positive root and a negative root. Okay, so keep that in mind when you take the square root of both sides of these types of equations here. So let me make this general rule here, right? Let me put it in here. Let me say in general, let me say this. That's an either. In general, let me say that if I have x squared equal to some number k, and this k may not be a perfect square. In this case, in this example here, k is what? K is 9 in here. Here is what? K is what? 144. So these happen to be perfect squares. But again, k need not be a perfect square. So if in other words, if you have x squared equal to some number, then x is going to be equal to plus or minus. Again, you take the square of both sides, you get plus or minus the square root of that number. So in other words, we're saying, in this case, we're saying x squared, I'm sorry, not x squared, but x is equal to plus or minus the square root of 144, but that's what? That's just 12. Okay, so that's why x is equal to what? Plus or minus 12 here. All right? Again, keep this concept in mind again. If you have a perfect square and a number on the other side, then you can take the square root of both sides, and k is a positive number. So let me just say that k is greater than or equal to 0. All right, is 0 or bigger. If k is a negative number and you take the square root of a negative number, what happens? Well, that's not a real number. If you remember that back in chapter 10. All right. So again, if you have a perfect square, such as x squared, equal to a non-negative number, either 0 or bigger, that is, right? So let's call it a positive number. Then x is equal to what? Plus or minus the square root of that number. All right? Let me squeeze one more example using this concept down here so you can see a little bit more of this here on the screen before I clear it out. All right? Let's look at x squared equal to, let's make it something like 50. For example, so here's a number that's not a perfect square. So here, in this case, I cannot solve this by factoring like I did over here, right? Since this number is not a perfect square, then even if I subtract 50 on both sides, even if I minus 50 on both sides, I'm not going to get the difference of two perfect squares because 50 is not a perfect square like 9 is right here. All right? So here, I need to use this technique of what? Taking the square root of both sides. So if I take the square root of both sides then of this equation, then I get x equal to, again, plus or minus the square root of 50, all right? Plus or minus the square root of k, right? K is 50, right? In this case, right? So now I need to simplify it, right? That's 25 times 2, right? We've simplified this radical before, so what comes out from 25? Well, 5 comes out. Can we see that? So therefore, my final answer is going to be x equal to plus or minus, what? 5 on the outside, and what's 2 on the inside. square root of 2. Sorry for writing so close to the edge here, but hopefully you can see it clear enough. All right, so therefore my final solution to this equation, x squared equal to 50, is what? X equal to plus or minus 5 radical 2. Okay, let's try another one. Let me go and clear out the screen. Again, keep this concept up here in mind right here. All right, let me go and clear it out. So bottom line is what? When you take the square root of both sides, then you always get plus or minus as your answer here. Let's try another one. Let's look at something like this. Let's look at x squared equal to, let's make it equal to 128, let's say. Or, yeah, 128 is fine. Let's make it 128. Okay, so again, 120 is not a perfect square though, right? But again, let's take the square root of both sides. So once I have a perfect square equal to a number, I can what? Take the square root of both sides to finish solving it. So I'm going to have square root of x squared equal to plus or minus the square root of 128. All right, so this is going to be x equal to, now let me simplify that. That's 64 times 2. I hope you can figure it out after you think about it a little bit, right? Again, remember how we simplify these square roots? We factor the radicand with the highest factor being, with the highest perfect square being one of the factors. In this case, 64 is the highest perfect square that will factor 128. So therefore, what comes out from the 64? Well, 8 comes out. So my final answer is going to be, let me write lower. My final answer is going to be what then? 8 on the outside plus or minus, oops, screwed up, sorry about that. Try that again. 8 here coming out, right? So it's going to be plus or minus, sorry about that, 8 square root of 2. My apologies. X equals plus or minus 8 radical 2. Let's do one more here since I kind of botched this example on you a little bit. Let's try this one. X squared equal to 48. Again, take the square root of both sides. That's the theme of this section here. So you get plus or minus radical 48. When you take the square root of x squared, you always get plus or minus. Keep that in mind. So therefore, you get x equal to plus or minus. Again, that's 16 times 3, right, for 48. So 16, what comes out from a 16? 4 comes out. So I have plus or minus 4 square root of what? 3 left on the inside. Okay, so that's our solution here. All right, let's extend this concept just a little bit. Let's try this one. Let's look at the quantity x minus 2 quantity squared equal to, let's make it equal to, let's make it equal to 12, for example. All right. So again, I have a perfect square here. X minus 2 is being squared, right? So that's a perfect square. So again, once you have a perfect square equal to another number, who cares if you have a minus 2 in here? Again, my point is this whole quantity is being squared. That means you have a perfect square isolated on the left-hand side. And when that happens, you can take the square root of both sides. So let's take the square root of x minus 2 quantity squared, and that will be equal to plus or minus radical 12. Again, you always get plus or minus when you take the square root of both sides, bottom line. So then we get what? X minus 2 there, right? Again, a square, perfect square, and a square root just cancels each other, right? X minus 2 equal to plus or minus. Again, what comes out here? This is 4 times 3, so what comes out? 2. 2 comes out. 2 comes out. Okay? So we get 2 square root of what? 3. All right? Now let's finish solving for x, because I still have to get x by itself. Just simply what? Add 2 to both sides. Can we see that? All right? So it takes care of the 2's here. All right? So therefore I get x equal to what? Now, when you write the final answer here for this problem, again, these two things, don't add 2 and 2 because you cannot, because 2 is, this is 2 radical 3, so these aren't like terms, so you cannot add them. So, but when you write your final answer, write the here's my plus or minus 2 root 3, so this is the plus or minus term right here. Here's a term that's just positive 2. So write your final answer with the non-plus or minus term first. In other words, write this number first down here before you write the plus or minus. In other words, write your answer as this. 2, positive 2, right, plus 2, plus or minus 2 radical 3. Okay, so this is how I want you to write the solution. But keep in mind, there are 2 answers here, right? There's what? There's 2 plus 2 radical 3 as the first answer, and 2 what? Minus 2 radical 3 as the second answer. But again, I can lump them together as plus or minus. But keep in mind, again, this means there's 2 answers here. Okay? So there's our solution to this quadratic equation. All right? Let's try another one here. Let me go and clear up the screen. Let's look at the quantity x plus 5 quantity squared equal to, let's make it equal to equal to 49, for example. All right? So again, let's take the square root of both sides here, right? So I get x plus 5. Again, square root and square go away. So x plus 5 equal to plus or minus what? In this case, 49 happens to be what? A perfect square. So it's just plus or minus what? 7. But again, anytime you square root both sides, you always get what? Plus or minus. Bottom line, I can't say that enough. Anytime I take the square root of both sides of the equation, I always get what? Plus or minus. All right, keep that in mind. Okay, then, let's finish it off. So let's go and subtract 5 on both sides. All right, so x is equal to, again, write the non-plus or minus term first. So negative 5 plus or minus what? 7. All right, but again, look at this problem here. Are these like terms, negative 5 and 7? Well, in this case, previously, remember I had what? I had 2 plus or minus 2 radical 3. Those weren't like terms, but these are numbers. These are just regular integers, so these are like terms. So I cannot leave my answer like this. I need to what? I need to simplify some more. In other words, I need to break this up into two answers. Isn't this negative 5 plus 7 and negative 5 minus 7? Can we see that? All right. So that's going to be positive 2 here. Can we see that? And what? Negative what? 12 here. So what I'm trying to say is, if you can combine these two numbers, in this case I can, then I need to do that by breaking it up into what? Two separate answers. Can we see that? My final answer is what? Positive 2 and what? Negative 12. Okay, so there's your final solution here in this case. So be careful with these types of problems here. All right, let's go ahead and try another one here. I'm going to put it out the screen. Let's try it out. Let's look at let's look at this one here. Let's look at this one here. Let's look at this example here. Let's look at 4 times the quantity x minus 1 quantity squared, all right, equal to 40, for example. All right, let's try this one. All right, now what happens? Well, I have this additional 4 on the outside. So that means what? That means my perfect square has not been isolated. Here's my perfect square term, x minus 1 quantity squared. Yeah, 4 happened to be a perfect square. Maybe I should make this a 2 here, so as an example, but that's okay. I'll leave it as a 4. But again, my point here is that since 4 is being multiplied to this perfect square, the first thing you got to do is you need to divide out 4. That's what we're trying to say here. Okay, so 4's drop off. So I have x minus 1 quantity squared equal to what? 10. 40 over 4. All right. Now, once I have the perfect square isolated, I want to take the square root of both sides. So now I'm going to square root both sides. So I have x minus 1 equal to, again, square root of a perfect square will take care of the square. Okay? They cancel each other out. Think of it that way. X minus 1 equal to what? Plus, again, always get plus or minus when you take the square root of both sides, all right? Radical 10. All right? So just simply add 1 to both sides to finish it off. So my answer is going to be x equal to 1. I'm going to write the non-plus or minus term first, positive 1, plus or minus radical what? Square root of what? 10. Okay, can we see that? Yeah, that's not too bad here. Let me take one more example in here. How about this one? How about y plus 3 quantity squared minus 8 is equal to, let's make it equal to, equal to 6 here, for example. Okay, so here again, I need to first we need to isolate this. Here's my perfect square term. First, I need to isolate that. So how do I do that? Well, I need to get rid of this 8 right here. So let me add 8 to both sides. Okay, can we see that? So I get y plus 3 quantity squared is equal to 14. All right, 6 plus 8. Now I take the square root of both sides. Once I have the perfect square isolated, I can square root both sides. Again, when I do that, though, I get plus or minus. So y plus 3 is equal to what? Plus or minus radical 14, which I cannot simplify. That's 2 times 7, but nothing comes out. So I'll leave it like that. All right? So therefore, let's subtract 3 on both sides to finish this problem. So my solution down here will be what? Negative 3. Write the non-plus or minus term first. Negative 3 minus 3 plus or minus the square root of what? 14. Okay, once again, keep in mind, though, there are two answers here again, right? Negative 3 plus root 14, negative 3 minus the square root of 14. Okay, now let's take a look at working backwards from quadratic equations. Here's what I mean by that. If I give you the solutions to a quadratic equation, can you come up with the right equation? So let's go and recall how we solve real quickly again, right? So basically, let's say we have some standard quadratic equations such as x squared minus, let's say, 5x minus 5x, let's say minus 24 equal to 0, for example, right? So we factor it, obviously, and solve it. So pay attention to the factoring here if we're working backwards, right? So let's say this will be what, x minus 8, for example, and x what, plus 3, right, to satisfy this factoring equal to 0, right? And we set the factors to 0, we're going to get x equal to 8, right? And that's an 8 right there, sorry about that, and negative, what, 3, right? And we set x plus 3 to equal to 0. So if we work backwards, if I give you these two solutions to start with, right, can we go back to the original equation? Well, of course we can, because from these solutions, we can see that we can come up with these two factors, for example, right? So here's how we can do that. So to solve this, we have to set each of these factors to 0. Well, from this solution, then I can get this an equation like that, right? So in other words, x equal to 8 implies that the equation, one of the factors is be x minus 8. Okay, equal to 0, right? One of the equations that we have to solve right from here, right? And x equal to negative 3 implies what? That x plus 3 equal to 0 is the equation we have to solve to get that. So from these solutions, we can obviously come up with these two factors, and then we simply multiply out these factors again to get back to the original equation. All right? So let's go and try that. So let's say I give you this problem. Let's go ahead and find a quadratic equation. A quadratic equation. All right, with solutions. Let's say 9 and let's say 9 and 5, for example. All right. So how do we come up with that? Well, again, let's look at what that implies, right? Let's see what the factors will be. So x equal to 9 is the first solution. Well, what do you think that implies? Well, what is the equation we have to solve to get this solution of 9? Well, we're going to solve this equation, x minus 9 equal to 0 to get 9 as the solution. So that means what? X minus 9 is a factor of the quadratic equation we're looking for, right? Similarly, x equal to 5 means what? X minus 5 that we have to solve equal to 0 to get that solution, which means that x minus 5 is the other factor for the quadratic equation we're looking for. So once we have two factors, we simply multiply them together to get the quadratic equation. So in other words, the equation we're looking for is going to be x minus 9 times x minus 5 equal to 0. And if I FOIL that out, I'm going to get what? X squared, take your time on that, but negative 9x, negative 5x, negative what? 14x, right? And then negative 9, negative 5, positive 45 equal to 0. Right, that's a 4 right there, sorry about that. So therefore, we have x squared minus 14x plus 45 equal to 0, which will give us these two solutions of 9 and 5. Okay, let's go and try another one. Let me go and clear out the screen. All right, let's go ahead and take a look at find equation. Let's say find, real quickly, find quadratic equation with solutions. Let's say negative 7 and 11. All right, negative 7 and 11 will be the solutions. Well, again, let's come up with the factoring, right? So so negative 7, right? That's going to be what? What's going to be a factor? That's going to be x plus 7 equal to 0. That's an x right there. Sorry about that. Let me go write it again. Sorry about that. This sketch pad is getting tough to work with, but x plus 7 equal to 0. All right, and 11, again, that's just like the earlier example, x minus 11 equal to 0. So that's 11 right there. Sorry about that. All right, 11. Okay, so therefore the two factors will be what? X plus 7 and x minus 11. So our equation will be x plus 7 times x minus 11 equal to 0. So therefore, if I FOIL that out, I'm going to get x squared. All right, positive 7x, negative 11x will be what? Negative 4x. All right, 711 minus 77 equal to 0. So the equation, quadratic equation we're looking for, what? X squared
minus 4x minus 77 equal to 0. Okay, let's go and try another one. I'm going to clear off the screen. All right, so what about this one? And what about something like, so let me just say solutions. Solutions are, let's say, 1/2 and 2/5. Solutions are 1/2 and 2/5 this time. Find equation. Find quadratic equation. Okay. Now, 1/2 is a little bit more tricky with this equation needing fractions as answers, right? But simply work backwards a little bit, right? So what does that mean? X equal to 1/2 is a solution. Well, if I start from here, let me multiply both sides by 2 to get rid of this 1/2. Get rid of 2 on the bottom here. Let's times both sides by 2. So I'm working with the first solution 1/2. I'm trying to figure out what is the equation I need to solve to get x equal to 1/2 as the solution. Well, if I multiply both sides by 2, I work backwards a little bit. You see that you get 2x is equal to 1. And if I subtract 1 to both sides, working backwards, right, you're going to get 2x minus 1 equal to 0. In other words, if I solve this equation here, 2x minus 1 equals 0, I'm going to get 1/2 as the answer. So therefore, 2x minus 1 is going to be one of my factors for this quadratic equation. All right. Same thing here. Let's look at 2/5. Again, if I started with 2/5, all right, if I start with that solution, let me times both sides by 5 to get rid of the 5 here, right? Get rid of 5. So you get 5x, okay, so equal to 2. All right. Again, if I subtract 2 on both sides, just like we did from the earlier factor here, then you're going to see that 5x minus 2 equal to 0. Sketchpad problem here, sorry guys. Let's try it again. 5x minus 2 equal to 0. And you see that if I solve this equation, I get 2/5 as my solution. So my two factors will be what? 2x minus 1 here and 5x minus 2 here for this second solution. So I just need to times them together to get the quadratic equation I need. So it's going to be 2x minus 1 times 5x minus 2 equal to what? 0 again. Okay, but I do have to times this out, so let's take our time on it. If I show some work here, or do this in your head, it's up to you, but that's going to be 10x squared. All right, minus what? 4x. All right, distribute the -1, negative 5x. And -1 and -2, positive 2, plus 2, equal to 0. So basically the quadratic equation that leads to these two solutions will be what? 10x squared minus what? 9x plus 2, equal to 0. So this is the quadratic equation that I have to solve to get these two as my solutions, these two numbers. All right. So again, with fractions, a little bit more tricky, but hopefully you can see the logic there. All right. Let's go and try another one here. Let's take a look at solutions. Solutions. The two solutions are. Let me write that a little better. Sorry again about a sketch pad. Let's say the solutions are x equal to negative 3/4 and positive 2/3. Right, these are two of my solutions. Let's come up with the quadratic equation. Again, what will the two factors be? Again, how do I get negative 3/4 from what equation do I need to solve? Well, again, let's start with x equal to negative 3/4 here, and sort of work our way backwards. So that's a 4 right there. Sorry about that. We'll times both sides by 4. All right, takes care of that. So 4x. That's a 4 right there. Sorry, 4x equal to what? Negative 3. All right, that's a 4 right there again. Sorry about that. And just add 3 to both sides. All right, so we're going to get 4x plus 3 equal to 0. So 4x plus 3 equal to 0. So the first factor will be 4x plus 3 because that will lead me to negative 3/4 being the solution if I solve this equation. All right. Second one is going to be what? Well, again, similarly, we'll times by 3 again to work backwards. And you can skip some of these steps and do it in your head if you are comfortable enough with this process. So we get 3x equal to 2. Again, just subtract the 2 over. So we get 3x minus 2 is equal to 0. So again, that will be my other factor. 3x minus 2 equals 0. So these two factors are going to be what I need to form the quadratic equation. So therefore, we're going to get 4x plus 3, all right, equal to, not equal to, times 3x minus 2 equal to 0. All right. Now again, just FOIL it out. 4x and 3x is what? 12x squared. Let me just do that in my head, if you will. Skip the intermediate step right here. So what's the middle term going to be? Well, here's what. This is inner is positive 9x. Outer is what? Negative 8x. Not positive 9, negative 8. Net is what? Positive 1x. Positive 1x. All right, plus x then. And constant 3 and negative 2, negative 6. All right, so my quadratic equation here will be what for these two solutions? 12x squared plus x minus 6 equal to 0. That's 0 right there. Sorry about that. All right. So again, hopefully you get the idea here. Again, this is 4x here. Let me just cross it off. Maybe make it look a little better. 4x. Well, not much better. Sorry, the sketchpad's not cooperating, but that should have been 4x right here. Sorry about that. All right. Anyways, hopefully you can still see the example clear enough to understand the concept of working backwards from the solutions to get the original quadratic equation. All right. So hopefully that's not going to be too bad. Okay, here are the Blackboard problems for this section here. All right, so number 1 is going to solve these 3 problems here. Number 1, solved by a factoring problem in this quadratic equation. The quantity 3x minus 2 times 2x plus 1 equal to 3x squared minus 11x minus 10. So solve this quadratic equation, simplify the left-hand side first, and then solve the equation by factoring properly. All right, number 2. Write a quadratic equation with integer coefficients with solutions 5/4 and negative 3/8. So the two solutions given are 5/4 and negative 3/8. See if you can work backwards and find a quadratic equation with these two solutions. All right. Number 3, solve this quadratic equation. 3 times the quantity x plus 2, quantity squared, minus 25 equal to 11. All right. So try out these problems and post them into Blackboard, and we'll go over it in class. All right. Until next time.